All right, and now here's another really fun thing with OlyDbg. Everybody loves OlyDbg. It has been around forever and it's used to cheat on Windows games and such. So OlyDbg, this is advanced dynamic analysis in user land anyway. So you download, first you hack PuTTY just to have a program. So you download PuTTY, and when you run PuTTY, it just makes a network connection to a server. So you can do SSH, which is a harmless little program, but it turns out to be fun to hack this program. And when you connect, it prints out the message login as. So if you load it in OlyDbg, OlyDbg will show you the assembly code that's about to be run. When you load code in Debugger, it breaks and stops running. At the bottom right, it will tell you paused, and then it lets you examine the code or change things before you run it. So if you run it, it'll launch and you can run it as usual, and you'll see it put in login as. So now if you reload it, now you can search for referenced text strings in Oly. Right-click search for all referenced text strings, and it will give you a list of all the strings that are used in commands in Oly. And you can search for that message, login as, and you'll find there are two places it's used. And this is what debuggers are for. You then set a breakpoint by pressing F2, turns red. That breakpoint will stop when it uses that string, which is what you want, because you want to find the code that prints that message. So now you just run it again and connect, and it will stop when it hits the breakpoint. So now you know the address of the code that uses that string, and you can now modify it. And this, remember, we talked about how functions are used. I'm going to call a function, which is ultimately going to print something. And first it pushes a pointer to that string. So this 467C7C is the pointer to where that string starts. So if you alter that, you can just change it in Oly. You can take away the breakpoints, and you can just assemble and change that number, 467C7C to 467C7D. And all that's going to do is move one byte over, so it's going to skip the first letter in the message. And now, if you run that program, it prints login as. So this is not very exciting, but it does show that you have control of the assembly code, and you can now modify programs so you can do a lot more fun. It's really pretty painful to save a modified file in Oly. You have to do it in a few steps, and I finally learned it and put it here so you get it right. But then you can save the modified PuTTY. And so you can do more fun things here. You can change the login message. Instead of just moving over a letter, you can go down to the data section, and you can edit this message, login as. You can change it to something else like Badness and save that file. And now when you run it, it'll print Badness on the screen. And then that shows you what you can do. And you can even add a whole Metasploit malware to this to do anything else, like open a reverse shell or so on. But the next thing that's really fun, I got this from the EasyCTF a few years ago, and it was wonderful. This is a wonderful game to learn assembler. You have these simple files, and these files are just password guessing games. You run this game, it will say launch codes and ask you for a number, and if you get the wrong number, which you always do, it just insults you. If you were somehow to get the right number, it would give you one letter as a prize. So if you look at this game is incredibly simple. The whole game is just about 20 lines of assembler. And on the far right, OlyDbg gives you a layout that lets you almost easily read it in C. So string is launch codes. That's what this is. And then you call puts, which is the C command, or think maybe C++ to print it on the screen. Now that's C. Then you read a number from the user with scanf. Then down here you print you win, or here you print you lose. So in between here is where it decides whether you were correct. So you don't really need to read the details of this assembly code to find out what's happening here. It prints something, it reads something from the user, then it moves some things around, then it does a comparison of something, and then it does a jump with not zero. So if that comparison results in not zero, it goes one way, otherwise it goes here. So this is the heart of it. Those two commands are what check to see if I'm correct, and then do an if I'm not correct. And if it doesn't jump, then it prints you win. So all I have to do is to knock out those commands so nothing happens. And then whatever I put in, it will accept it as correct. So you just replace those with nops. And now You save that file, and now you've got a game where whatever you give it, it gives you the answer. So this is how you cheated on the game. So that's good, clean fun. And now you can just start patching them. Patch 3 of them to get a code, and then you can figure out how to automate the patching in Python, where you automatically read in the file, modify the bytes, write a new file, and automatically run it. That's all very easy to do in Python. So you can do 19 and you can do 256 of them. And the original challenge had 67,000, but I decided this was enough. Anyway, so that's good, clean fun. And that's why everybody loves OlyDbg. It makes it very easy to debug normal Windows programs and modify them. And here's something from the Flare VM last year or the year before that was good. They had all these modified versions of Minesweeper. So the Windows XP Minesweeper, I modified it and called it MineSam. And now you can hack into it. And what you can do is learn how to cheat in Minesweeper, which is extremely easy with OlyDbg. You can just view the memory. If you view the memory that's used by this program, you'll find it has a text section, a data section, and a resource section. And you can just dump the contents of the data section. And when you look at it, it's got a lot of zeros. But when you start playing the game and click something, this fills in, and it's obviously the game board in a simple way. You have you can see you have A's and B's. The A's are where you have a 1, the B's are where you have a 2, the 0F is an empty square, and you can even tell where the mines are. It's a very simple pattern. So you can make an automated cheater for Minesweeper. You get proc dump from Microsoft, which dumps the memory from process, and then you make a Python script that just finds the game board and prints it out. So you can make a cheating script that will show you the game board where the mines are. So now that you can cheat, there's a few challenges here where you try various levels, and there are flags that appear when you solve various levels by cheating. Anyway, so that's fun stuff to get you started learning how to use OlyDbg. Let me save this one.